Hi, everybody. This is Mr. Folly, and welcome to 1.6 Photoelectron Spectroscopy, but we will call it by our old friend's name, PES. So, let's see if I can write PES. There we go. All right. Photoelectron spectroscopy describes electrons through a graph with humps. You can tell that those are my words because that doesn't sound very textbook-like. This right here is phosphorus. Bum, bum, bum. The electron configuration of phosphorus is 1s2, 2s2, 2p3. Okay, if you look at your periodic table, you can confirm that. Okay. An energetic photon is shot at an atom of phosphorus, and we detect the energy, To kick off an electron, okay, we detect the energy to kick off an electron one at a time. The electron is ejected if enough energy, doesn't need to be an exact specific number, hits it. If I added 1,000 kilojoules, right, it would kick out every electron on the left, okay? So this takes, 1, 2, 11, 15, and then this would be 700. So if I have 1,000, that's enough energy to kick off all of them. Notice how this is a logarithmic scale, okay? So there's big jumps, okay? 10 kilojoules would kick out only, here's 10, right? Only kick out these guys, right? So let's see what we can do. The number of peaks tells us the subshells involved, S, P, D, and F, and it goes in order from what we learned. So if we're looking at this, 1s has to be somewhere. 1s is closest to the nucleus, so it would take the most energy. So notice the most energy to kick off 1s. Then comes 2s. Now, 2s2 should be very close. Did I write something in there? 2s2 should be the exact same height as 1s2. Okay. Notice how this one is, 3 times taller. So that means it would be, that means it would be 2p6. Okay, I'm apparently missing, this is not phosphorus. 1s2, 2s2, 2p6, 3s2, 3p3 is phosphorus. I'm sorry, I gave you nitrogen instead of phosphorus. Okay, then this would be, notice same height as the 2, 3s2, and this is just half again as tall, so this would be 3p3. So you see how that arranges itself? And I'm so sorry. Make sure you put down wrong electron configuration for phosphorus to get yourself a bonus punto on the quiz tomorrow. Okay. The number of peaks tells us the subshells involved. So 1s2, 2s2, 2p6, labeled like that. The height, relative height, of the peaks tells us how many electrons are in each shell. And you can usually base it with 1s2 because everything starts with 1s2. Order. The origin of the graph may be where the largest energy. So normally if I draw a graph, this is 0 and this is 100. And this one, notice how this is 1,000 and this is 0. Okay. Distance of the peaks. Changing an energy level roughly changes by a factor of 10. Okay, so if I'm looking at this I'm going to erase my numbers here. Notice how this is, about 1. This is about 11, and this would be about, I'm not very good at estimating my logarithmic scales here. I guess this wouldn't be logarithmic because it's from 10 to be 100. Let's call it 700. But you can tell it's very different. You can see the breaks, first energy level, second energy level, third energy level, right? First energy level, second energy level, third energy level. Okay. All right, here's nitrogen. Nitrogen's right here. Boop, boop. It has 3 peaks. So nitrogen is 1s2, 2s2, 2p, 1, 2, 3. So the biggest energy is going to be at 1s. So if I have to draw this and estimate it, I guess I'd go, okay, my first one's going to be, my first one is going to be this tall. That's my 1s2. 2s2 should be in the next grouping here. So 2s2, same height. And then 2p3 should be a little bit taller and close by. So if I had to rough it out, I would do that. Notice how I changed if they give you markings, you want to put them in a different marking for every energy level. And do you see how that's the difference? What order? Remember, the 1s goes closest to the highest energy one. And how tall? Based on 2 or 3. What element is this? Okay, so this is the biggest energy. Big energy. So that means this right here is 1s2. Okay. This part right here would be 2s2. So this part right here would have to be 2p. Uh-oh, let's see how we do measuring. Ooh, is that 2p3 or 2p4? Oh, wait, I got little graph lines here, don't I? So this is 1.5. So this one would be 1, 2, 3, 4, 5.5. So on this, you'd have better lines to do this. But we'll call this, let's say if we think it's 2p5, the element it would be fluorine. If we think it's 2p6 would be not fluorine, but next to fluorine is neon. And just know that AP Chem gives you that kind of flexibility when reading a mediocrely labeled graph. Simulated PES spectrum of scandium. The 1s peak occurs at 433 and is not shown. Oh, that means 1s is all the way over here. Whoops, how did I put that? I keep making it an A. 1s2. So that means this is 2s2 because that's the biggest number. This is going to be 2p6 because there's more. 3s2, same height. 3p6. Oh no! Oh no! Huh. This height is the same as the other one, so it's going to be 4s2. And then I got a little nub in here. Well, it's half the height, so it's going to be a 1. But what's going to come after 4s2? That must be 3d1. So this is one where we have to count on ourselves to be smart. We see this little nubbin here. It's like, ooh, nubbin, what are you doing? And that little nubbin has to be explained. You might think, well, that would be 4s2 because it comes first. But notice the height. The height equals the other s's, so it's going to be a 1. So that's going to be it. So which electrons are represented at 0.77 peak? We did that, 3d1. Which electrons are lost when scandium forms Sc plus 2? Remember, you lose the valence electrons, okay? And you're going to lose your lowest energy electrons. Well, the lowest energy electrons would be these ones. I should have changed my color. I'll change it to purple. Maybe that'll override it. Oh, yeah, that makes it illegible. This is my lowest energy one, so I'm going to lose my 4s2. Right? And you should know you always lose the valence electrons and ions. All right. Ionization energy, i.e. is the energy to remove a valence electron. The amount of energy needed to remove an electron is easily calculated. The energy of photons shot at a sample is chosen. I'm going to shoot 100. Okay. The energy of the electron removed is recorded. I'm an electron. I'm an electron. Then I have 20 is my, we'll call it joules. 20 joules is my energy. I'm going to make my electron read more like an electron. All right. How much is the difference between the two? 100 minus 20 is 80 joules. That's your ionization energy. Okay. So here we go. 30 picojoules. We got ourselves a little 30 PJs. Shot and a 13. My electron has 13 picojoules. Is emitted. What is the ionization energy? Well, that would be 30 minus 13, 17 picojoules. There are second and third ionization energies, but these don't show up in PES. And you know what else doesn't show up in PES? The smiles on our faces for being done. So for that, I will say toodles.